Hello everyone, good evening. This is Kiran, the trainer joining.
Good evening, Karan.
Let me share my screen. Yeah, a quick recap. Yesterday we discussed about what is an API. API stands for Application Programming Interface, and it helps you to transfer the data from one module to another module in the form of in the form of JSON or XML or text format or YAML format or HTML format. And we discussed that text to HTML formats are outdated. XML is 90% outdated, but 10% being used in the industry today. JSON is the most preferred format today. JSON stands for JavaScript Object Notation. It follows key and value pair structure. That was a very quick recap of what we discussed yesterday. And today we will focus on the API client and API server architecture. Something very important for all of us to understand, because this topic forms the basis for understanding API testing as well. So let me put some diagrams as well on my Paint application so that we understand. So I'll say this is my client, and I will say this is my server. So this is the client application, and this is the server application. And what are we talking today? Client and server architecture. And if I may ask this question, what is client? Can anyone give me an answer? According to you, what is a client? Anyone? What is a client?
A system or application who is requesting the service.
Okay, perfect. And Priyanka says browser, which is also a perfect answer. Yeah, I think I got the answers. So a client is typically any application or a device that submits a request, right? So a client is an application or a device that submits a request. And example of client application is the world's favorite application, which is browser, Chrome browser, Firefox browser, Edge browser, Safari browser, Internet Explorer, all the browsers. In our course, I'm teaching you a tool called Postman. Postman is also a client. Okay? And if you're working with, let's say, Eclipse editor, then Eclipse IDE is also an client. Like this, there are so many clients in the world, millions of examples we can write. But I guess browser is one favorite client, and Postman tool that I'm using is also a client. So a client is nothing but someone who sends a request. Okay? So to whom this guy will send a request? Obviously to the server. So let me draw a line here like this and say this guy is sending a request. Fine. So let us also write here that this guy is sending a request, and it is called API request because we are talking about APIs. Okay. Now the next question. Again, feel free to answer this. What is a server? According to you, what is a server? Okay, I'll tell. A server again is an application or a device that receives a client request to analyze the request, process it, and give back a response. So a server is an application or a device that receives client request to analyze it, comma, process it, and submit a response to the client. That is the definition of server. And example of server is there are application servers, there are web servers, there are email servers, there are FTP servers, there are infrastructure servers. Typically, I would classify the servers into two categories: application servers or web servers and infrastructure servers. So example of app servers or web servers will be, you have Apache Tomcat, you have Nginx, you have IBM WebSphere, you have Microsoft IIS servers, then you have Glassfish server, then you have Cloud Front server, then you have etc. I think the list continues. So many servers are there. So these are all the server containers where the software code is deployed by the developers. And if I talk about infrastructure servers, which provide the physical hardware, you have examples like AWS servers, Microsoft Azure servers, Google Cloud servers, third-party providers like Control-S. Okay, so many are there like this. We can write down. Okay, so these are infrastructure providers. And what does the server do? It will give back a response to the client. So I'll draw the line like this, then arrow like this. And I will say it will give back an API response. Okay. Now, most of the times when someone asks you what is a client and what is a server and what is the architecture all about, most of us assume that client sends a request, server gives a response. That's it. That is the end of client and server architecture. That is what I assumed a couple of years back. And that is what most of the people might also have assumed, but that's a wrong thing. Whatever we assume, like client sends a request and server gives back a response, is just 10% of the overall client and server architecture definition, which means we are missing out 90% of things. Okay, so we are missing out 90% of the things in client and server architecture. So let us discuss about the remaining 90% as well. I'll try to see if I can complete them today, otherwise tomorrow. Now I want you guys to be a little interactive with me in this class. That's when it becomes very much beautiful. Can someone give me an example of a request? So I said client is sending a request, right? So can someone give me saying, Kiran, this is an example of a request?
When we send any message on WhatsApp, so we send it, that's a request.
Okay. Any other examples?
A login request.
Login request, good. Next.
Search for information.
Correct, searching for something. Otherwise?
Placing an order.
Yeah, perfect. Placing an order is also
Add a
correct.
card.
Yeah.
Add card.
Add to cart, perfect. Otherwise, I can simply say, even if I type
Checkout.
even if I type amazon.in, that's a request, right? Simple. Whatever browsing you do on the browser, everything is a request. Or if I type here news.google.com, that is also a request I have, right? So all these things are nothing but our request only. So this is one example of a request that I'm typing here. So I will say here, example of a request is this. Now, when I sent this request through my client, which is the Chrome browser, did I receive a response? Of course, yes, right? I'm seeing a lot of information coming up on the website. In which format you think the response is rendered on the browser? Text format, HTML format, XML format, JSON format. Choose one.
It will be HTML.
It will be HTML. Any website, always 99% you got the response in HTML format. So I'm writing here under API response that I got a response in HTML. Meaning client sent a request called amazon.in. Who is the client here? My browser. It went to server. To which server it went? Amazon server, because the domain name is Amazon. So the request went to Amazon server. Amazon handled it and it gave me a response. And that response I received it here in the form of HTML. So this is some simple client and server architecture I explained. Let me take one more example. right? Like you told, add to cart, making a payment, sending a message, sending an email. I will type some other request. Okay. Whatever request I'm typing, you may be aware of it, you may not be aware of it. So it does not matter even if you are not aware of it. It's just like Amazon.in. So this is a request I have with me and I'm sending it on the server. Sorry, from the client, it went to server. So this is one request I have. So whatever you see in the address bar is obviously a request. So I will say this is my second example of a request that I submitted on the browser. And when I pressed enter, you see something got printed here. This is not as beautiful as Amazon.in because Amazon.in gave a HTML. It's a web application. This is a small API I have. I just submitted it on the browser and I got some response. Looking at the response, can you guys take a clue whether it is in text format or HTML or XML or JSON?
It's JSON.
JSON form.
It's in JSON format. Clue is very easy. It is following the key and value pair structure. Everywhere there is a key on the left side and there is a value on the right side. So it's a JSON example. So I can write here at the bottom that this time I sent a request and the response I got is JSON response. You see, in two different examples, common point is I'm getting a response. Differentiator is sometimes I'm getting in HTML format, sometimes I'm getting in JSON format. Let me change the example now. I'm typing one more request on my browser and you see I got a response. So this is the request I submitted on my browser. I'll just keep it here for our reference. And did we get a response? Yes, I'm able to see here. Looking at it, can you take a clue in which format it is printed?
XML.
XML, because it clearly says on the top, this XML file does not something something. So we got a response in XML format. Let me take one more example here. And I pressed enter. This is the URL. This is the request I have submitted on my browser. And you see, I got some response and it is in text format because you can see here txt. So this is in text format. It is difficult to identify which is in text format, so I'm telling it directly. Yeah, so we got the response in text format. So the key takeaway for you and me is when you send a request from your client, which is your browser or probably Postman tool, when I start teaching you, you will definitely get response, but the response can be in HTML format or JSON format or XML format or text format. That you do not know until and unless you see the response body. Okay, so takeaway from this little 5 minutes discussion is the response will come, but in any format, which is dependent on the server and the way the developer has programmed it. Okay, now let's move a little forward. Every time you send an API request, right? Every time you send this API request, the request is accompanied by something called protocol. Every request that goes from client to server is accompanied by protocol. I'm sure all of you have heard of the word protocol, right? So what do you think the definition of protocol is and what is it? Can anyone talk a little bit about it?
Set of
Protocol
rules.
is set of rules.
Perfect. Protocol is a set of rules and regulations that tells how clients and server can communicate with each other. So let me write it here. So I'll say it is a set of rules and regulations that governs how client and server can communicate with each other. Okay. See, something like this. In the definition, I said client is sending a request, and in the definition, I said server is giving a response. But why should server give a response? What if server has ego problems and says, sorry, client, I'm not happy with you. I will not give you a response. Just imagine a human behavior here. But will that happen? Never, right? Server will never say that I will not respond to you because I hate you or because I have ego problems with you. That never happens with server and client. The job of client is to submit a request. The job of server is to process it and give it a response. But how are they doing it so disciplined? The answer is protocol. So protocol is the secret ingredient that is helping the client always send a request. And protocol is an ingredient that is helping server capture the request, process it, and give back a response to client. So client and server are disciplined in nature because of someone called protocol. Just like when you come with your vehicle on the road in your respective cities, you are all disciplined, right? Like when you see a traffic signal, red light, your vehicle will stop because you are aware that a police can take a picture of yours and then challan you. When it is green, you have to move forward because you know that that's the discipline you are taught. Otherwise, there is one, I mean, I don't know what to call, but the police guys, they'll take a picture, they'll challan you, they'll make your life miserable, right? So that discipline is there because of police. Similarly, here that police is nothing but protocol. So there are different types of protocols in the internet, right? I'm sure you're all aware of it. There are, I don't know if it is hundreds or not, but there are minimum 20, 30, 40, 50 protocols out there. Let me see how many I remember. We have protocols like HTTP, HTTPS, FTP, SFTP, MQTT, file protocol, SQL protocol, JMS protocol, IMAP protocol, POP3 protocol, SMTP protocol, LDAP protocol. Then we have GraphQL protocol. WebSocket is a protocol, which is actually WS protocol. Then WebSocket secured WSS is another protocol we have. Okay, etc. Okay, maybe JDBC is another protocol that we can use, etc. So many protocols out there in the industry, and every protocol has a purpose. Okay? Now, if the question is like, why do we have so many protocols? Why not one protocol? Simple. In Hyderabad, the left turn is always free when you're on the roads, but in Bangalore, the left turn is not free. You will be challaned if you take a free left turn when there is a red signal. You have to stop your vehicle when there is red. But in Hyderabad, even if it is blinking red, you can still take a free left turn. You can still take a free right turn, meaning U-turn, not right turn, right turn, U-turn, not right turn. So each city has a different rules when it comes to traffic. Like in India, we drive on the left side of the road, but in let's say Saudi or in United States, we drive on the right side of the road. Right? So protocol is different for different cities, different geographies. Similarly, in the internet, for achieving different kinds of business activities or user interactions, we have different protocols. So we have HTTP protocol and HTTPS protocol to transfer the data from one module to another module, from client to server. FTP and SFTP protocols are used only to transfer files from client to server, server to client. MQTT protocol is used to handle big data, big volume of data that social media is generating, what YouTube is generating, Google is generating, Twitter, LinkedIn, Facebook, Instagram, all these rubbish social media applications, whatever huge data they generate, MQTT protocol is used to handle that data. File protocol is used by Windows operating system to minimize the file, to restore the file, to change the size of the file, to close the file, to save the file. SQL protocol is used in relational database management systems, okay, where you write SQL queries. Java messaging services is used in Java. IMAP protocol and POP3 protocol is used for receiving emails, for receiving messages. SMTP protocol is used for sending messages and sending emails. LDAP protocol is used in Windows Active Directory. GraphQL protocol is used by Facebook for API technology. WebSocket and WebSocket Secured, they are used in live streaming or uh, cryptocurrency or in share market, stock market. JDBC protocol is used in relational database management systems. So every protocol has a reason and a different thing to work with. Now, the intention is not to teach all these protocols to you. In API testing, what protocols we use, that is the important thing. So here, mostly we use two protocols. We use here HTTP, which is unsecured protocol, and we use HTTPS protocol, which is a secured protocol. These are the two protocols that we should be good at in terms of understanding for us to talk about API testing. Okay? I'm sure from the college days or from your first day of job, you have been hearing the word HTTP, HTTPS, right? Question 1, what is the full form for HTTP?
Hypertext.
Hypertext
transfer protocol.
Okay, so hypertext transfer protocol. Perfect.
Protocol.
And any idea when was this protocol introduced in the internet?
In 96 or 98, maybe?
Yeah, that's correct. So I would say introduced in Web 1.0 era. So those 1990s here, we call it as Web 1.0 era. Okay. Now, a point that you have to note about HTTP protocol is it is an unsecured protocol. Unsecured protocol means, let me write here, it is unsecured protocol, which means whatever data we are sending from client to server or whatever data we're getting from server to client, it is not guaranteed. Meaning it can reach the destination or it can be dropped in between, it can be stolen in between by a hacker. That's why this protocol is called unsecured protocol, because by design it is unsecured. So unsecured protocol by design, which means the data delivery is not guaranteed between client and server. I'll give a simple example to understand what do I mean by data delivery. So in the diagram, you see, let's say the client is sending 100 rupees. Assume that client is sending 100 rupees to the server. Okay, imagine through Google Pay or whatever, it is sending 100 rupees through HTTP protocol. Okay, and in between, a hacker who can steal your data tampers it and changes it to 10 rupees. And when it goes to server, server says, oh, thank you, client, I received your 10 rupees. Server is under the assumption that client shared 10 rupees. But client shared how much? 100 rupees. So let us say there was a loan between client and server. Client says, okay, loan is closed with server. Server says that 90 rupees is still pending. But who ate that 90 rupees? Hacker ate it. Client always assumes that I sent 100 rupees. Server assumes that I got only 10 rupees because client sent only 10 rupees. But hacker who stole the data, his identity is not known to server. His identity is not known to client. That is what I mean by the data delivery is not guaranteed. Similarly, let us say in another way, the server is giving a acknowledgement saying thank you with a smiley icon. Okay, because it got some money. And while it is going back, the hacker can change the message, maybe from thank you smiley icon to kind of unhappy icon. And when the message goes to client thinks that, hey, when I gave him 100 rupees and closed the deal, why the server is unhappy? Client assumes that server is so adamant because it is not even having a smile on the face, right? You might say, why can't client talk to server and say, hey, why are you sending me this kind of smiley? Client and server are stateless. Once they send a response or request, they forget what they have done. It's like a memory loss patient. Okay, I'll talk about serverless later. Stateless feature. Client and server and the HTTP protocol is a stateless. Stateless means they forget what they said, like a memory loss patient. In the movie Gajini, if you have heard of that movie, where the hero plays a character, it's like that. Okay, so the problem here is HTTP protocol is not reliable because the data guaranteed is not there. Why it is not there? That's how they designed it in the web 1.0 era. Because in 1996, 1998, do you think we had Facebook, Instagram? Do you think we had like, share, comment, subscribe? No. Do you think we had YouTube? No. Do you think we had Gmail? No. Do you think we had internet banking? No. Do you think any online thing was present? Nothing. It was all about a digital newspaper those days in 1998, where you type abcd.com and you see the heroine, you see the hero, you see the movie articles, you see the news. That's it. You cannot log in because there is no login feature. You cannot like, subscribe, share, comment, blah 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 blah. So security is not necessary because it was a digital newspaper, nothing beyond it in 1990s, which is called web 1.0 era. Hence all the websites that were developed in web 1.0, they followed HTTP protocol. But slowly from the year 1999 or 2000 onwards, the concept of email came into picture, where Yahoo made a revolution, Cool Mail came into picture, Hotmail came into picture. They made a big revolution. That's when the industry decided that we should think of having a secured protocol. That's when the brother of HTTP came, which we call it as HTTPS. So HTTPS stands for Hypertext Transfer Protocol with security. That S stands for security. And it was introduced in Web 2.0 era, meaning from 2000 onwards. And it is a secured protocol by design, unlike HTTP. And here the data delivery is guaranteed between client and server, which means if client says, okay, I have to send 100 rupees to my server, if it is going and a hacker sees this 100 rupees, hacker will see something like this. Hacker does not know that this meaning is 100. Hacker cannot tamper it. So definitely 100 rupees only will go to server. And when the server says thanks with a smiley icon as a response, the same message comes. And when hacker wants to steal it, he will see something else. He will not understand. He cannot do anything with it. So therefore, the same message will go as it is to client. And point that you have to notice, the data is transferred in encrypted format in HTTPS, whereas in HTTP, the data is transferred in plain or clear text format. Okay, so that is the difference between HTTP and HTTPS. Okay. And another thing that you have to probably understand is, how did the industry prepare HTTPS? Like, what was the magic they did to prepare HTTPS? The answer is simple. They used cryptographic protocols. So cryptographic protocols were used, such as SSL or TLS, to convert HTTP to HTTPS. Okay, so I'll talk about what I meant. So what they did is they used HTTP and they added a cryptographic protocol SSL. That's when HTTPS was formed. And in the later days, SSL became outdated. Then they used TLS and HTTPS came. So this is latest today as we speak, and this is outdated. SSL is no longer recommended. TLS is recommended. So the marriage between old protocol and a cryptographic protocol called SSL made HTTPS. Like a bachelor, when he gets married, when he goes through the marriage process, his status changes from single to committed, something like that. Okay? Now, SSL stands for Secure Sockets Layer, and TLS stands for Transport Layer Security. Okay, and within TLS, we had multiple subversions. We had TLS version 1.0, TLS version 1.1, TLS version 1.2, TLS version 1.3. So today 1.3 is latest and 1.2 is outdated, because hackers are able to steal the data even if you are using these things. And secure sockets layer is outdated and TLS is recommended. So whatever is outdated, I'll put it in red color. Okay, so this is about the next thing in the client and server architecture. Every API request that you send from client will accompany a protocol. The protocol can be either HTTP or HTTPS. If the protocol is HTTP, in your API, you have a bug because your data is not safe. If the API is using HTTPS protocol, your API is safe. So two test cases here, if you are understanding test cases related to protocol. So I will say the first thing we have is verify if the API, I'll say ensure the protocol used in the API request is not HTTP. Ensure the protocol used in the API request is HTTPS. These are the two test cases that you should first think of. Third test case is ensure the cryptographic protocol used in the API request is not SSL. And ensure the cryptographic protocol used in the API request is TLS version. Okay, it is TLS. And I will say ensure the cryptographic protocol used in the API request is here. I'll say TLS version 1.3 is not TLS version 1.0, version 1.1, version 1.2 because they're all outdated. Okay, so these are 5 test cases that you can keep in your mind when you're talking about API test cases related to protocol. Am I clear to everyone until this point?
How we can validate which TLS version they have used?
Yeah,
By
good
looking
question.
at the endpoint.
Yeah, I'm going to answer that. So if I take this API, whatever I was executing on the browser. So when you look at the address bar, tell me which protocol they have used, HTTP or HTTPS?
TPS.
HTTPS, because you can see clearly here. Now the question that Priyanka had becomes relevant. Now, is this using SSL or TLS? If it is TLS, what version of TLS they are using? You can directly get the answer from your browser only. So right click on your browser and click on inspect. You can right click anywhere on your browser, click on inspect. This will open the Chrome developer tools. And on the top, you have elements, console, source, network. Like this, if you come, there is something called security. Click on security. Once you come to security, refresh the page on your browser. So I'm refreshing the browser. Once I refresh the browser, here you see I'm getting one option, HTTP, your URL, whatever you visited. Click on this. Once you click here, you see what is the protocol they have used? TLS, not SSL. And which version of TLS? 1.2, which is outdated. So I found a bug with regards to API they have developed because it is an outdated version. Okay, so this is a bug we found. I'll show it one more time with another request. Let's say I will take you to Isha Training Solutions website. Okay, now here we know that they are using HTTPS. Very good. What I'll do, I'll right click on the browser, I'll click on inspect. Here I'll click on security. And once you come to security, you have to reload the browser again, otherwise it won't tell you. Reload the browser, and here under main section, click on your website name. And here you can see what is the protocol they used, TLS version 1.3. This is how we can figure out how to capture the protocol details.
See, Kiran,
Clear?
I see one more protocol, QUIC.
That's another flavor of protocol few websites are using. I think if you use Udemy also, you get something like that.
Yeah, Playwright. Yeah.
Okay, Udemy is using TLS 1.3. So some websites use something else. They're all, another flavors of your TLS protocols. But I mean, you can Google it, but 95% we see TLS 1.3.
And even the Google, I think Google.com also using QIC.
Yeah, this QIC. Even I have seen it multiple times. Let's just do Google. What is QIC protocol? Okay, it's a UDP internet connection. Okay, it's a user datagram protocol. Other ones are normal TCP protocols. It is a UDP protocol, another flavor. But I think that should be okay. Whatever number we see, right? QIC is also okay.
Do we test for it in application whenever we make a API testing? The first thing, do we check for these?
Yes, we do that. Okay. Yeah. Okay. So now we discussed about protocol, which means we made some 20% progress. We know what is a request, what is a response, we know protocol. The next thing that we should understand is every time you send a request from client to the server, the request will contain a protocol. Along with protocol, it will also send something called HTTP method. Okay, HTTP method or HTTP verbs. I'm sure you heard of this, right? HTTP methods, HTTP verbs.
Yes.
Yes.
Yeah. Okay, you've heard of it. Very good. So now the question is, what is HTTP method? I want a definition. And I'm sure the answers will come, which is a definition, which is an example. Can anyone define what is HTTP method?
It will be like type of request that client requests the server.
Yeah, perfect. Very, very correct. So HTTP methods, it is also called as HTTP verbs. So the definition is simple. It describes the type of client request being sent to server. If I have to relate it to regular examples, let's say, Vicky is my friend and I'll say, hey, Vicky, I need some help. Okay. Now, when I say I need some help, now Vicky, if he's intelligent, he will say, what type of help? Like, is it some attendance related help that I have to capture for the training program? Or is it about the payment that I have to make? Or is it about some money you are borrowing from me? Or is it about some other guidance you need in life? Right? So favor can mean anything, right? So what favor I want from Wiki or what help I need from Wiki, that is what this is talking about. So what type of request client is sending, that server also wanted to know, right? So in the diagram, you see client said, I'm sending a request to you. Server is not an idiot to say that, okay, you send a request, I'll give response. No, server is also intelligent. And it says, client, I definitely know that you have taken life in this planet to send a request. But what type of request you are sending? Why can't you explicitly mention that? So that server is prepared to give an answer. So to help a server understand what type of request we are sending to the server, we use this one, HTTP methods. And there are multiple HTTP methods available. We'll talk about few. Okay, we don't have to talk about all of them because we are not developers. So example, we have get method, post method, put method, patch method, delete method. I'll explain only these, but others are also there like options, head, echo, trace. Then we have debug, info, etc. So many other HTTP methods are there. And based on the requirement, we use them. Okay, there's a question from Karthik. Who defines this protocol to be used? Obviously, you're a developer. The project requirement defines it. And in 99%, not 99, 100% of the times, it is always HTTPS. You don't even have to take a decision. It should always be HTTPS. And it should always be TLS version 1.3, because whatever is latest, that is what you have to buy. That is what you have to use. Yeah. So these are the different HTTP methods available to help the server understand what type of request client is sending. So let us talk about the definition of these methods. So the definition of, so one thing you have to remember is all these HTTP methods starting from get to delete, they are sent by client, okay, to the server. It is never sent by server to client. Please remember that. So get method is used when the client requirement is to get the data from the database, right? So the definition of get is this HTTP method is used by client to retrieve or to read or to fetch the existing data from the database or from the server. Okay, and this is similar to your select query in database languages. Okay, little similar to select query in database language or in SQL. Okay, so what is the meaning of get? So it is used to tell the server that, hey server, you have a database, you have a lot of data in it. I want some data from it. So can you please give it to me? When this is a kind of favor client wants, it uses get method. Something like, I have been speaking to you, right? Non-stop 45 minutes. Obviously, I'm feeling thirsty. So what would I do? I'll say, to my kids, to my wife that, hey, can you give me a glass of water? So am I asking something which is present in my home, or am I asking something which is not present in my home? When I say glass of water, it is present in my home. It is present in everyone's kitchen. So that's a get request because I'm asking something that exists. If I ask my wife now, hey, get me, a glass of apple juice. What if we don't have it at kitchen, inside the kitchen? She has to make an order, probably on Swiggy, or she has to go to the market, buy the fruits and come and prepare it. So that's not a get request. So you ask for something which is present, that is called a get request. Okay. So again, I'll take, if let's say if I take Priyanka, I'll say, hey Priyanka, can you please transfer 10 rupees to my Google Pay? If Priyanka has 10 rupees, it's a get request. Now, when I say, hey Priyanka, can you transfer 1 million rupees to my account? If Priyanka does not have it, it is not a get request. Forget about whether Priyanka will give it to Kiran or not. If she has it, it becomes a get request because I'm asking something that she has. If I'm asking something that Uday does not have, it is never a get request. So what examples we can think technically for get request? You ask server something which it has. Example, I'm typing amazon.in.
Is it a HTTP method or HTTPS method get? There you written HTTP method.
No. This HTTP is not protocol. Okay. Protocol discussion is over. We call it as HTTP methods. It is never called as HTTPS methods. By default, it is called HTTP methods only. Okay. Yeah. So coming to examples of get request, browsing a web application is an example of get request because I'm asking something which is present. So amazon.in, the moment I typed, I'm getting a response, which means the website development for amazon.in is already present. So I got a response. So it's a get request. Similarly, if I type news.google.com, I'm getting the response because what I typed is existing. So that is also a get request. Similarly, you go to your amazon.in and then you click on view your existing orders. Then it will say, okay, the order is dispatched. It will be delivered by tomorrow. So viewing order details is an example of get method because you are viewing the details of an order which is already present, right? Then I will say downloading a file from the internet. from your Google Drive, if you download a file, or from your photos, Google Photos, you are downloading a photo. That is also GET request because you are downloading something that is present. That is there. Downloading your pay slips is also a GET request. And reading an existing or old email or a message is also an example of GET request because that message is there already on your phone. It's an old message, it is already present on the database. They're all examples of GET request. Is the GET clear for everyone?
So Kiran, I have a question here. See, if a client is requesting something, and if I think all the time client might not know whether the request, what the client has sent, will be served by the server. Sometimes we get page not found error. Even that is also a response from the server, right?
Correct.
So
So
the request, the client is not completely fulfilled, but we got some response from the server, even if that is not existing with the server.
okay. So your question is, let us say I'm typing google.com. Since that request is valid and I'm getting a response, it is a GET request. Correct. And if I type google.com/kiran.html, now this page does not exist on the server. So when I press enter, server is giving an error.
4.4. Yes.
Correct. This error is coming. Now your question is this a GET request or it is something else?
Exactly.
Yeah. So this is also a GET request only because you are asking the server, I want to get the data at the Google domain for a page called kiran.html. So you assumed that it is present there. Server said, okay, probably it was present yesterday. It was present a few seconds back. Now it is not present. Hence, I'm giving you an error. Client believed it is present, but it is not present. So server has to give a response, whether it has the required information or it does not have the required information. It will still be treated as a GET request only. Okay. See, anything you are asking for server, which a server has or server does not have, you are asking server, give it to me. It is a GET request. Server will say, I have it, but I will not give it to you. Server says, I have it, I am giving it to you. Server says, I never had it, so I cannot give it to you. These are the three possibilities that you can have from server. Like I am asking you, please give me 100 rupees. You have it, you may not give it. That is also still GET request. You don't have it, still I will say it's a GET request. You have it and you are willing to give it to me. That's still a GET request. Because every request can have a success response or a failure response. So I was talking more from a success response perspective, but your question now made me talk about negative response perspective as well. Did I answer your question?
Yeah, Kiran, yeah. Thank you.
Yeah. Then we have post method. So this HTTP method is used by client to create new resource or new data on the server or on the database. And this is similar to your insert query in SQL language. So every time client may not expect server to give existing data. Sometimes I will have a different type of request, right? For example, in the morning, I had food. In the afternoon also I had food. In the evening also I will have food. In the morning it is probably breakfast. Maybe idli or dosa is what I'll have. In the afternoon I might have biryani. In the evening I might have curd rice or I might have some tiffin or I might have some healthy snack and then that's it. I'm consuming food, but the type of food is changing. Meaning every time I want to eat something, my request to the kitchen will be different. Similarly, whatever request client is sending to server, sometimes the request could be give me existing data. But sometimes I get bored with existing data. So I might tell the server that, hey server, you are becoming little outdated. Let's create something new. Right? It's like refreshing your wardrobe. Every time there is a festival, what do I do? Like, do I wash the clothes and just wear it? No, I go to the shop, or you go to the shop and then you buy new clothes, right? You are creating new item in the wardrobe. Similarly, client also wanted server to renew some data. Not renew, I would say create some new data based on the need. So whenever you are doing something on the internet and that action is triggering creation of new data on the database or on the server, that request will use post method. Example, let's say I'm not happy with water because I'm still feeling thirsty. I'll tell my wife, hey, don't mind, but get me one apple juice. Now she will go and prepare the juice. So she is not giving me existing thing. She is creating a juice for me and she is giving it to me. That's a post method. Technically speaking, if I have to talk about technical examples, creating a new order on Amazon because I wanted to purchase iPhone. So I purchased iPhone, so a new order is created once you make a payment. A new order getting created is like new data getting created. So that's an example of post method. Uploading a file to the Google Drive or Google Photos or to your email or anywhere. Uploading a file is like creating a new file on the database. Sending emails or sending messages on social media. They're all examples of create method. And another example I can take is user sign up to any website. You might sign up to Instagram, Facebook, Gmail, etc. So this action is making the database to say that I have a new entry in my database. A new candidate is joining us. So employee onboarding to a new organization is an example of post method. Is this clear, guys? Post method?
So in general, Kiran, like can we say anything adding to the database can be considered as a post method?
Yes.
Okay.
Any action that you do on the internet, that will be your post. Then we have put method. Put is used when you wanted to tell the server that, hey, your data is very old. Let's update it. Let's modify it. Let's replace it. Like I am selling my old bike and bringing in a new Royal Enfield. Or I'm selling my Royal Enfield, I'm bringing in a new Harley Davidson bike. So I'm kind of exchanging old bike for a new bike, old car for a new car. That's like put. So when you do some update actions on the database, it's called put or patch method. So this HTTP method is used by client to update or to modify or to replace existing data with the new data on the database or on the server. And this is similar to update query in SQL terminology. Okay. And coming to the examples, again, I'll take the example of the juice. Let's say my wife brought me that apple juice and I'm having it. And I somehow feel that 1 spoon of honey will make it much better. Okay. 1 spoon of sugar will make it better for me to drink. So I'll tell my wife, saying, hey, why don't you bring 1 spoon of sugar, put it inside the glass and stir it well. So that's like updating the juice, right? She's not preparing the juice again. You are updating the juice, which is already prepared. That's like a put action. Technical examples can be, I will say, updating user profile. In Facebook, we update, right? Something like that. Or updating WhatsApp display picture. Or editing a sent message in Gmail or WhatsApp. All these are examples. And another best example I generally use is changing your password in Outlook, Gmail, or any other domain that you use. All these are actions that you are updating the data. Okay, and in the shopping cart, you update the quantity, right? Updating the quantity of items in shop cart that you have added. They're all examples of put method because you are updating your data. Am I clear, guys, on put?
So just in case, let's say their record doesn't exist and we are trying to put call there, will it insert a record? Like, will it treat as a post or no?
Yeah, good question. So put is a powerful method. If the object you are trying to update does not exist, it gets created immediately. Okay, put can work like post also. And coming to patch method, it is similar to put method. The only difference is it can update only partial items, meaning selective items. Put can update all the items or partial items if you want, but patch can do only selective items, meaning out of 10 fields, if you want to update all the 10 fields, then you have to use put only. You cannot use patch. But out of 10 fields, you want to update less than 10 fields, patch can be used. Because patch means patch work only, small updates only, not full updates. If you want full updates, all the field updates, always go for put method. If you are looking for selective updates or small updates, then patch method can be used. So developers mostly they recommend put method because put can work like patch if needed, or put can work like put and post also. Patch is little outdated, I would say. And delete, the name itself is a self-explanatory.
Can you please explain the patch example? Anything?
Like if you take your user profile in Facebook, open your Facebook, and if you click on edit, you get some 10-15 fields to update, right? First name, last name, gender,
Yes.
date of birth. Yeah. So those fields.
Only
if
some
you're
fields
updating,
only.
correct. If you're updating less fields, it is patch.
Okay. Okay, thank you.
Finally, the delete method self-explanatory. This HTTP method is used by client to delete existing data on the database or on the server. And this is similar to delete query in SQL. And the example is deleting messages, deleting your emails, deactivating social media accounts, etc. So any action that you do on the internet and that is deleting, that's nothing
So
but delete.
1 minute. Sorry for interrupting.
Yeah.
So the patch that you are telling now, is that similar to what you were telling yesterday, like the mandatory fields, when you fill a form with the mandatory fields and with the optional fields, like is it similar to that?
No, that is in the payload, that is different.
Okay.
Don't worry about these methods now. We will do much more deep diving once we come to the APIs.
Yeah. Okay. Yeah. Thank you.
Okay. Yeah. So here the HTTP methods that we have are get, post, put, patch, delete. Okay. So get is used for read operations, post is used for create, put is used for update, and delete is used for delete. Essentially, we call all these actions as CRUD actions. CRUD operations testing. C stands for create, R stands for read the data, U stands for update, D stands for delete. Create means post method, read means get method, update means put or patch method, D means delete method. So if someone says, do you know what is CRUD operations? It is nothing but using all these HTTP methods to test your APIs. And how to test it, you will come to know in the upcoming classes. Okay. Yeah, Vinodini, there is a WhatsApp group in the chat. I think you're already part of it. Yep. So that's all I have for today's class, guys. We have discussed about some 40 to 50% of, not 40% of API client and server architecture. I'll continue the stuff tomorrow again. And if you are enjoying the classes, please complete your enrollments. Tomorrow I'll complete the client and server architecture. Okay. And if you have any questions, I'll take them tomorrow. Thank you very much for your time. Good night.
So Kiran, you sharing these as attachments also, right, to the playlist? How?
No, the notes will be shared only after we finalize the students. For the first 3 days,
okay,
the video recordings will be shared.
So after that, after finalizing, you're going to share this data also, right?
Yes,
the notes.
yes, you will get it. Yes.
Okay, thank you.
Okay, guys. Thank you very much. I'll see you tomorrow. Take care. Bye bye.
Thank you.
Yeah, thank you.